I'm Anil Kumar, and in this video we'll see how to write a polynomial equation from the given zeros, how to sketch a graph, and also find few characteristics, correct? So that's the exercise which we are going to do in this video, and I hope that helps. The question here is, write equation for the following polynomial. A quintic polynomial with zeros -1 order 3 and 3 order 2 that passes through the point -2, 50. So let's understand each term. First one we are given as quintic, means degree 5. Now we are given zeros, so we have 0 at x equals to -1 order 3, right? That means the factor should be x plus 1 cubed. Do you see that? That's the first 0. The second one, we are again given a 0, which is at x equals to 3, and the order is 2. That means x minus 3 whole square is your factor, correct? So this information can be translated as degree 5, 2 zeros, one of order 3, the other one of 2. When you multiply, you get degree 5. And we are also given a point, we'll call this point P, as -250, right? So that's the information which is given to us. Based on this information, we can always write a function f of x as a times the factor x plus 1 whole cube times the other factor x minus 3 whole square. To find the value of a, we'll substitute the point -250. So y value is 50. A minus 2 plus 1 whole cube minus 2 minus 3 whole square. So that gives us 50 equals to a times -2 plus 1 is -1 cube times -5 square. And that gives you 50 equals to a times -1, and this is 50, 5 square, which is 25, right? Positive 25, okay. So that is -25. We can find a as 50 divided by -25. That gives us a value of -2, right? So a is -2 for us. So we have found the value for a. That means we can write the polynomial. So let me write down the polynomial f of x now as a is -2, so it is -2, x plus 1 whole cube, x minus 3 square, correct? So that becomes the polynomial. So we first thing write polynomial equation for the given condition. It is f of x equals to -2 x plus 1 whole cube times x minus 3 whole square, correct? So that is a quintic polynomial. If you add 3 and 2, you get 5. Zeros at -1 order 3, at 3 order 2, correct? And we found the value of a by using the point -250. Is that okay? Now let's try to understand how to sketch this polynomial, right? So I'll sketch it here, and then we'll discuss few characteristics. So we have zeros at -1 and 3, so I'll just draw a line, y-axis right there. So -1, let's say this is 0 at -1, and then we have 0 at 3. Now now when we see the leading coefficient is negative, so therefore the quadrant, it will start from quadrant 2 and end in quadrant 4. That's the end behavior, right? Now this one is degree 3, that means it will go like a cubic function, kind of like this. Do you see that? And here we have squares will turn like a parabola. Is that okay? Now we can join these points to sketch the graph. So we could say that the quintic function will look like this. Is it okay? So that becomes the graph for the given polynomial, where the point minus 2, so this is at 0 at minus 1, right? This is minus 1. So let's say minus 2 somewhere here. So this point, we'll say this is the point P for us, which at minus 2 is 50. Is it okay? And this point is the second 0, which is at 3 of order 2. Right? So that is how you could sketch your graph. Now you can see it doesn't have any symmetry, right? And this graph has a domain as expected. Domain as x belongs to real numbers, range y belongs to real numbers, zeros are given to us, and end behavior as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches negative infinity, right? So it moves from quadrant 2 to quadrant 4. So that's the kind of graph you get for the given conditions, right? I'm Anil Kumar, and I hope that helps. If you like, you can share my videos with your friends and post questions. Thank you and all the best.